with the session today, and today's session is on unit test. Just feel free to message on the chat. I'll look in the chat in parallel. Uh, Let me share my screen now. Yep. Let me know if you're able to see my screen. Um, uh, yep. Thanks. Thank you. So the first one will is on the unit test. So one of the key things for unit test, even before I start with other aspect, is right. Um, it's one of those skills that is not appreciated enough. Some teams do appreciate it, but a lot of the teams are there which do not appreciate, writing unit tests. I mean, they all know that it is good to have, but they don't. They don't understand the gravity of it. I have teams where unit test was always an afterthought that we just kind of write it at the end of the day. But that's pretty. I mean, there are a lot of benefits of writing those unit test cases. One of the things that from the book that we have, the clean code, in that book, he has mentioned that we should be writing more. This is basically canvassing for the of approach of using test-driven development. I have tried that, but yeah, doesn't work for me. But other than that, having said that, you can kind of still go and write unit test cases. You really do not need to follow that approach. But yeah, if you are comfortable with it, you can kind of go ahead and do that. So that's my 2 cents on that. But the advantages that come with unit test, as we go through it, we'll just go through some of those things. I will also bring out some of the things that I've experienced during that session. So the today's content, yeah. So what I'll do is we'll go through the 3 laws of TDD. TDD is test-driven development. Then I'll go to what are the clean tests that should be there. And then the second is we go to like, there are two philosophies around that. The one is like whether you want to do one assert per test or you want to do a single concept per test. So yeah, I mean, he mentions that we kind of can do single concept per test, but we also look at what we can do with one asset per set. How does that look like in different scenarios? And the last bit, it talks about how do we write unit tests, like what are the main principles behind those unit tests around it. So that's what we are going to cover. Before going forward, do you have any specific questions that you can pop into the chat? All right. Yeah. Yeah. Just feel free to push in those questions in as I go through, and I'll just try to answer them uh, immediately. So we'll go to the 3 laws of TDD. So the way the test-driven development works is like you don't write code. You first write the test, and when you write a test, obviously the test will fail. And the first law states that you don't write production code until you have written a failing unit test. So you write a failing unit test, and obviously it will not have those objects that you want for those tests. So that will fail, and then you go and write the code where you add those new objects that needs to be tested. But then again, there will be some compilation error because not everything is there, and then you need to kind of cycle around that approach. So yeah, so that's a overall concept of test-driven development. But yeah, I mean, I'm fan of writing unit tests, but I'm not fan of writing using the TDD. But if anybody else has done it, yeah, you can kind of share what they have done it. Yeah, and we can take it forward on that one as well. Um, All right, I'll quickly move forward. So the next one is on the clean test. So one of the key fundamentals that we need to understand from a test unit test perspective is like the test needs to be at par quality of production code. When I say that at par, it's like whatever the test that we write, they are like the uh, yep. Let's go. Yeah. So whatever the test that we write, it has to be at par with the production code. And when we say at par, it means that the quality, the all the principles that we follow, like do not repeat yourself, and having the code which we write very easy to understand or readable code. All those principles applies to the test. It's not like something that you have written the entire code and now you're coming back okay to just like a checkbox activity that you do at the end of it saying you know what, okay, I've done written the unit test cases. That approach does not help you in especially in enterprise organizations because the problem is in enterprise organization the code is massive and there are a lot of changes that are happening in parallel, and what that does is that when what are the changes that you have done, you don't know whether what the consequences of the impact of those tests is, what the blast radius is, so as to speak. It's a term that I use, the blast radius, that you don't know what the blast radius is. Whatever the change you have done, you don't know. It might get affected into 100 different places. So you don't know the blast radius. The only way you can control that piece is by having this unit test cases. So one of the principles that we use when we have to write those test cases is like we try to cover as much as things in unit test, and that would kind of help us make any change. So yeah, so I'll get to your question. If you don't use TDD, then which approach you use for writing unit test? So there are multiple ways to do it. The one way that you can do it is like you can kind of write your base code. Can kind of write a bit of dirty code, kind of a thing, like a draft version of your code. And once you write that draft version of the code, then you can start writing your unit test. So what the draft version does is it kind of checks it. You kind of make the things work so that everything starts working together, and you know that thing is working like for the one proper test case. But then you go and you start adding test cases after the first version. So and then you can see whether the tests are passing or not. And this is a little bit tricky because when you are writing production code, you're trying to make it work, and then when you're testing it, you're trying to break or you're trying to find the scenarios that might come in, that might happen in production, and you want to protect your code from those scenarios. So there are two different types of thinking in this particular piece, and I think that's why many of the developers find it hard to write or they don't care about unit tests. Is because that you have to kind of switch your hat. Earlier, when you start off, you are writing a code to make it work, and then now there is a specific shift around it, saying that now you have to write test cases, which means you need to find out the boundary conditions. You need to think about the scenarios that might happen in production, and you might need to check whether your code will still work in different conditions, and yeah, all those scenarios. So that's a real you need some mental cycles around it. You need to spend some time around it to create those negative scenarios as well as the edge case conditions and everything. So I think that's one of the challenges like for most of the developers that they face. So the approach would be like you first write your draft code, then you start writing your test cases, try to test it. I mean, what the way you can do is like you can kind of take a break after you see your code is working, take a break of say 30 minutes or so, or if you want, you can kind of come back the next day and then write those unit test cases. Because when you're coming back the next day, a lot of things, your mind would have processed a lot of things, and it will start creating those scenarios for you. So that's one approach which you can do it like draft case, draft code. write your unit test cases, and then you refactor your draft code to make it production ready. So then what happens is like all your test cases, you just need to verify your test cases pass or not. That's one way. There's one more approach that I do is like if I'm not sure about what the production code should look like, in that scenario, what I do is I don't write TDD, but I write high level. So I write all the edge cases, everything on a notepad, saying these are my this is how it should work. Positive case, and then I write the negative scenarios. What are the negative scenarios that can happen? And then I also write the edge case scenarios, and so that becomes my it's more of an acceptance criteria. So these are the things that I need to take care when I'm writing the code. So I have this thing in my front of my mind is in a notepad, and then I obviously write my actual code, and then use just use all that nodes to create test cases around it. So that's another way of doing it. So what that does is like because you have written all the scenarios up front, your code will not code will have the base quality of the code will be much higher because you have thought about all those scenarios that were coming into that piece. So that's one approach. That's the second approach that you can take. So write it up in everything in the notes, and then write code so that your code conforms to the notepad that you have created. Then you go and write the test cases, which are basically a copy paste of whatever you have in notes around it. So it kind of you can kind of do it pretty quickly. And then once you've done the ones that you have covered from your notes, then you can kind of do a bit of exploratory testing kind of a thing where you still figure out, okay, go through each line of code and find out what are the scenarios that can happen that can break the code. So in that way, the code quality that comes out at the end of that whole process will be pretty high on that one. Uh, Hope I answered that question. I'll go to the next one you have mentioned. Uh, Yeah, so the question is like, at what point of time we say that the testing is done or efficient or complete? So one of the ways, as I said, if you write those scenarios out, you will know that you have covered most of the scenarios. Now, the other aspect that you have in your code would be you would have things there would be an if-else condition happening. So you need to cover. Talk about code coverage. Code coverage is that whatever that code you have written, you need to have all the lines covered in your test. So it just there are tools that are available on the open source, which yeah, I don't know which one. I don't remember which one, but yeah, there are simple tools that are there which would give you the code coverage percentage. So using that percentage, you will know whether you have completed, you have written all the test cases around it or not. So that's one way of doing it. And obviously, there are certain business scenarios that you need. There might be a specific business rule, so which you need to test it. So you will already know based on your requirement that these are the business rules that your code should satisfy, and that those are the things that needs to be covered in the unit test. And one more thing is that the way we do it, one of the practices that we have is like normally we push the code to production, and once we push the code to production, we find some bugs that come in, and then we fix the bug. Now, when we fix the bug, we create a corresponding unit test for that particular condition, so that in future nobody misses out that particular condition. So that's another way of covering up those scenarios which kind of get missed sometimes. Yeah, hopefully I have answered that. Yeah, I'll go back to clean test. Yeah, the last point is the most important point. Like there are people who write test unit test for the sake of writing unit test, but uh, that actually defeats the purpose. So one of the foundational principles of your code or any software is that the requirements are going to change. The software has to change at some point of time. The change is only constant there. So if you write dirty tests, what that means is it becomes hard for any new developer to understand what those tests are there for. And if they are failing, they don't know how to fix it. So because those tests are dirty, they do not want to invest time in fixing those tests. And thus, what that does is like when you have to make change to make there's a change, you need to make a change to production. you're not sure whether that change will cause an unwanted or unintended impact to some other part of the system. So that's why you have to ensure that the tests are significant part of the code. And like in many of the better organizations I know, what they do is they have so until you write those unit test cases, you cannot merge your pull request or anything like that. So that way the bar remains high, and people write good test cases as well. So that's other aspect of it. Um, I will move ahead to the next bit. Um, yeah. So what clean tests look like? It's follow the similar principles that we have been covering so far. The first is like proper naming conventions, give in better test names, and so on. And then and then there is a thing called given when then format. That this is mainly from the BDD, like behavioral driven development world, where you say that this is the condition that is given. And so if I talk about a scenario for login, so so given is like a user already has an existing login, and when is when the user enters user ID and password, and then would be whether the system should be able to validate the whether the user exists in the system. So most of the tests will be in that format. I'll try it. I'll share my code. I have some code to share. Stop share. Share. No. Yep. Yeah. I believe you can see my screen. So yes, still off the fine. Good. So now in behavioral driven development, we have an explicit given when and then statement that we use. But like you don't need to use that one. So I'll just go through one of these test cases. So if you look at it, it says get phone number, and then it says when customer ID is null, then return all phone numbers. So it's in the same format. Like when this customer ID is null, then you need to return all phone numbers. So that is it tells me that okay, that's the business rule that I'm testing. And then even here, if you look at it, the first bit is I have a list of phone numbers, and then there's a when, like whenever this phone report dot find out does, like it goes and needs to search. This is a mock basically. It's a mock. If you look at it's a mock using Mockito library. So we need to tell the mock what it should return. So it will return all these phone numbers, and then we are going to test the method like phone service dot get phone number, and then we put all this information there. It will test that particular method. So this particular format is generally it kind of everybody is kind of uses that same format. Like first you declare what are the data points are there. That's the part of the given, and then when is the mocks or anything other than that that comes in, and finally the then is the part where you kind of do an assertions on this aspect. Yeah. Uh, any questions? I'll just pause for questions. All right. Yeah, just pop in questions as you go, and I'll just answer. Um, the next bit is one of the things. It should be readable with minimal duplication. Now, this is one of the problems that you will have. I don't have a bad test case example actually, But the one of the problem that you'll have is like a lot of the code will be duplicated when there is a test case. So now I'll give an example. You have this particular test case where it's like if customer ID is present, then phone number with customer ID. And then what I've done is I've added all these assertions. And now if I have to, if I move from here, now there's another, I need to test one more condition saying that when customer ID is present, then phone number with customer ID. And this is just a thing that I'm adding. Just okay, I want customer ID with customer name. I don't want customer ID. Then when customer ID is present, then get customer name. I just need customer name. So along with this, I also need to test customer name. So what happens is uh, this generally the process that people follow, that you copy the one test case, you paste the whole thing again, and then what you do is you do an assertion here. Assert that if your name is test name, name dot like in an example, I just put anything in there. It will throw me an error. That's fine. So what would happen is like people, I've updated the test, but there's only one additional assertion that I need to test, but then I don't remove all these assertions. Now what that does is like when somebody else comes in and they read the test, they get the information from this particular thing, but the assertion that it has to test is like hidden. Here at least I put it somewhere outside, but sometimes this assertion would be in between all the lines of test code that you have, and then it becomes very hard for anybody to understand. Okay, what are we really testing? And we are all having all this duplicate code around the all over the place. So that's one of the problems that we have. So what we kind of have to do is like if it is only we need to just to do an assertion on customer name. So even if we call the same method, we don't need to assert all the other things. We just clean up all those things, and we just keep the main assertion that we are going to test. We wanted to test customer name is coming correctly or not, so we just put that assertion. We remove all the other things so that it becomes clearer. Okay, where the test actual test is. There's other way of doing it. There's other ways like you can kind of extract into a method, uh, saying that assert phone number, and then uh, in this particular thing, I can call this particular method. This is if you really want to still assert, you still want this assertion to happen, then you can kind of create those specific method and which can kind of use it. So it still makes it clearer because there's only one method. Somebody else wants to read it, they don't want to look into it, they can just simply look at this particular thing. So that's another way of to keeping it clean and removing the duplicates around it. And this is one of the biggest thing that happens. Like there's a lot of code duplication in unit test cases. Yeah. Well, I don't want to say that, but like a lot of the times, like developer feel lazy to do this thing. So, but keeping it clean, it kind of helps it because then you can avoid. First is it will tell you. So if I do one more thing I use, so if I just collapse everything, I will know what are the test cases I have testing. This just gives me a documentation kind of a thing on my code. If customer ID is null, then I return all phone numbers. If ID is present, then just return with customer ID. This is something I added, but then customer ID not found, return empty list. So this is like one of the scenario. Okay, if there are no customer, what should we do? Should we throw back an error or should we send back an empty list? So just reading this documentation, I will know that okay, if ID is not found, it will return an empty list. There's no error there. And if activate phone number, if present, then save in DB. That's another one. So it just becomes a documentation. All the business rules are being captured in this unit test sheet. So it kind of gives you what are the business rules are there and what are the tests that we are going to write it. Uh, yeah. Any questions? Yeah. You if you have those kind of combinations, right? You have a another thing called parameterized test, where you can pass all the different combinations into this parameterized test. And then for parameterized test, there are different inputs that you can send. You can also send it from an method, a static method from it, so that you can give a thing called at method source method. Yeah, so and then you give one what the method it needs to invoke, and then you put the method in, or you can give it in a CSV format as well. So it's a kind of a read CSV as well. So in those scenarios, so like all those different permutation combination, because your code remains the same, this particular code will remain the same. Even the you can have in this parameterized test, you can pass what is the input. So you can have like string input and string output, and then you can put. Uh, I'll just go CSV. CSV source, and then you can kind of explore this one. I don't remember it on top of my mind, but you can give. Uh, yeah, so there are a few ways to use. If you go look up parameterized test, it will give you. You can do it by CSV. You can do it by a method call, and also you can statically pass those inputs into this particular place, and it will. And you need to pass those parameters as a arguments to this particular method, and then you can test them. So that would cover your all the different combination that you want to test. I hope that's what you mentioned when you said all the combination. Yeah, all good. Uh, Let me see if I can share it properly. Share the screen. No. Screen. Yeah, I'm just sharing it again. Yeah, that's it. Slide in there. So that's what we were mentioning about readable with minimal duplication. And then we talk about covering all the multiple paths that code may traverse. And that is what, if I go to this phone service, I don't know, they have got different path. Yeah, I think this is one of the things that I wrote in one of the previous calls. So if you look at this particular call, it says there's a method called calculate RTO pricing, and we have a try and catch, and then there are multiple catch statements there. So when we say it has to cover all the paths, so we should when we test this particular method, we need to test what is inside the try, which does not throw an exception, and then we also test with if it throws an IO exception, and then it also we also need to test if it throws a runtime exception. So all the path that a code can take it can go through at any point of time. We need to add tests to it. So if we have all those tests, we know like there won't be any bugs related to the code that we have, it would be something missed out on the business side, or there's some edge case scenario that we might not have thought of. Those kind of bugs might be there, but your code essentially will not have any major bugs around it. If we try, ensure that we cover all these scenarios. It's not easy. It takes some time to, get all this thing done, but yeah, it's doable. Yeah, and the last one is again the code name and everything should make it easier to readable. Yeah, everywhere, whatever it just follow the same principles that we have. So if I use phone list and phone numbers, it will be list of phone numbers. Yeah, it's by default. Anybody reads it, it should be uh, easily understandable that it's what it is. Um, yep, and that's on the clean test. Okay, I'll just move ahead. I think we covered this one. It covers all the multiple paths. Then, yeah, one asset per test. I think in the book he has mentioned that it's not a hard and fast rule because it's hard to implement those kind of a thing. But what we can do is we can minimize a session so that a reader can understand why the test was written in the first place. So that was one of the things that I talked about, like minimizing the assertions. That even if though by creating this particular method, it uh, kind of removes the complexity for people to understand when they are seeing this. They know that it's asserting the phone number, and they can just see this assert equals. So that makes it a little bit clearer, and that's why. So even if there are actually not two, but more than, yeah, whatever the assert phone number method has got number of assertions. Yeah, it has got 1, 2, 3, 4, 4. So four assertions, and plus one, there are five assertions. But whenever, because we have minimized it by encapsulating into a method, we can only see there are two assertions, which is much more easier to understand. So yeah, either you try to minimize this or you try to, and especially when this kind of a thing happens where you are actually want to validate what is the map, what is the transformation that is coming in every field. You want to assert all of those things. That's why the rule that having one assert per test is not practical all the time. Sometimes it works. It's not a hard and fast rule. The only way you can look at it is minimize assertion, and I think even in the book he does mention that one. So uh, the next bit, yeah, is a single concept per test. Again, yeah, this is a much more practical approach because yeah, you have got you get an object back from a particular method, and then you want to test all the fields. But you can still say that you're only testing one concept. Okay, when customer ID is present, then return my uh, when customer ID is present, then return phone numbers with customer ID. That's it. So it just does one thing, and even if there all the other assertions are there, but we are just testing one concept, that whether this particular scenario is being met or not. That's it. Nothing other than that. So that's a much more practical way of doing it. Let's see. All right. Any questions? Okay. I'll move ahead. This is the last bit, uh, and I think this is one of the most important bit in this particular chapter. It talks about this first principle in terms of writing tests. So one of the first is like it should be fast. That is, test should be fast because you don't want to spend time running those tests. One of the biggest challenge is that most people have is getting these test runs fast because initially, because the code base is small, the test runs are okay. But as you add more complexity, the test starts taking more. So this happens especially with the regression scenarios that run. And what happens is like regression scenarios takes 3 hours, 4 hours, maybe a day to run. And what that means is like you cannot go to production because all those regression has to be done. And then if there's some failure, somebody has to go and investigate those failures. So it spend one day to run the test, and then after that it says, you know what, some this has failed. Then it becomes a big cycle of changes, and that's why we want to ensure that whatever we do, we try to ensure the tests are small, and if we write a big test, we try to cover only the high level scenarios for the big test, which takes more time. But all the smaller tests, we try to make it as fast as possible. The second challenge that is there is independent. The tests have to be independent because we want to be able to run them in parallel. So if you want to run them in parallel, if they are dependent on each other, then it's very hard to do it. So, and I'll show you an example here. So I've tested this repository test. It's basically a database, whether the sequels are working fine or not. That's what it does. So what I've done is for a before test method, I would set up all the required data, and then after each test method, I'm going and deleting, running a cleanup on the SQL. So that ensures that the test remains independent. There's no like some other there's a test that goes and added a data into the database, and that will affect. For example, you have this particular thing. In invalid customer, it should just return 0. But if some other test goes and updates with the same data, this can turn into 1, and then what that does is that your test becomes unreliable. So whenever you are writing those tests, you need to ensure that if you're adding a data, you need to remove it data before after the test gets over. You need to clean those tests up. Otherwise, you will not achieve that independence part of it. The next one aligned to that independence is repeatable. Yeah, the test should be repeatable. It should always be saying, yeah, it should always give the consistent results. So if something is breaking, then it changes. Now, this repeatability becomes a challenge if there's a concurrency scenario. So that's where if you keep the test independent, you can kind of achieve repeatability at a very good rate. But if your tests are dependent on each other, then that repeatability is where it kind of breaks. And yeah, and if it starts breaking because of that, and if nobody is fixing it, uh, then it then it starts adding, like it just goes on to this red scenario. So what people do is like, okay, I got 5 tests failing. I don't know why it is failing, but we know that in the production it works fine. So even with that red build, we kind of try to bypass it and push it to production. And which means those tests that are failing, they have become useless. So we need to ensure that tests don't fail. They should either pass all the time or they should fail all the time. It should not be like it passes in the first run, the second run if I run it, it should fail. It fails and so on. The next one is self-validating. Again, test should, as is evident, the test should say whether it passed or failed. It should not. People should not need to go into the logs and check whether the test passed or failed. It should automatically say whether the test has passed. So you need to have those assertions. Again, timely is on a similar concept that the result should come out as soon as possible. It should not like wait for like ages before it comes out. So, and one of the other aspect is like before anything, sometimes this does happen. Uh, you don't. There's a test case and there is no assertion in it. So what that does is the test will always pass, regardless of what happened in this particular thing. So your ID does warn you if this is the case, but yeah, sometimes people just miss that. So just ensure that you have an assertion in the first place. Without an assertion, there's no test to do it. And this does happen. Like you kind of miss out because you're already handling so much complexity. In that complexity, you might just miss out on writing those assertions. And if there's no assertion, there's no point of test. So that's another aspect of it. Yeah. Uh, any questions or any thoughts? I know we cannot interact as freely as we could do it in Google Meet. Sorry for that. I wanted to try this one, but yeah, this doesn't look good for our session. I'll change back to Google Meet. Yeah. Any questions? All right. All good. Yeah. And other than that, there are yeah, one thing that's not covered uh, in this particular in the book chapter is that these tests that you have, if you look at the way I have added this test, it's like there are unit testing and then there is component testing and there is black box testing. And it what it does is like unit test, we kind of test only the code, we mock everything else. So if you go here, sorry, that's an application test. Yeah, we go here. Yeah, you have all these mocks. We use Mockito, and we use a lot of mocks so that we don't test what the dependency is being tested. That's the basic test that we have called the unit test. And the second test, so this is like one of the terminals that we're using in one of the organizations that I work, is a repository test. Repository test is like a third party API. You're calling another API, you're calling another database, or yeah, it can be database API or any things, or it could be a cache and everything else. So what you try to do is you are sending some queries or some invoking that API, and then you want to find out whether the API is giving you the correct answer or correct expected output or not. So if it's a database, then you can kind of control it with test data and everything. If it's another API, yeah, you kind of have to deploy it on your like you put it as deploy it as like one of the Docker images for that particular API and kind of test with those things. So that's a different way of testing it. But what that does is it will ensure that sometimes what happens is all the behavior with the API is not documented. If it's a new or it's a third party API, that does not get documented. When people what they do is they do all the research, and once they do all the research, they put that finding in a document or somewhere, and then that document is lost. Nobody remembers the document after that. So instead of doing that, what a better approach is like you write test in your code base itself. By doing that, what that does is anybody who wants to go and validate that API, they can or want to find out what the behavior of API is. They don't need to go through, try to set up that API in the machine and everything. They can kind of go through the test and they will know what the behavior is. So that's another aspect of it. The last bit is your black box test. It's kind of an integration test, which kind that you want to run to just see whether the your code works end to end, and with the application getting deployed and all. So that's like an integration. So what we do is we minimize. I don't know, I've written 5 or 6, but we minimize the number of tests at this layer because the test at this layer is very expensive, and the tests at lower levels are much more cheaper. And the lowest is your unit test, which are the cheapest one because they are the most efficient and they're the fastest ones. So we try to focus on this one, but we need the bigger ones just to ensure that end to end things are looking good on one. So that's there. Uh, any questions? Final. Uh, all right. Fine then. I think I'm done for this particular session. Yeah. All right. As I said, I'll revert to the Google Meet. The only reason I tried this one was because Google Meet had some. I had to kind of send a separate mail on the Google Meet and everything. So I thought I will automate it. But here I don't see you guys, and I'm not getting that interaction that you used to get, which used to make the discussion very lively. So yeah, I'll revert to the Google Meet format the next time around. Yeah. All right. Thank you all. See you. Bye.